So if you know that if you have a structure, it's not all part of the structure are incomplete, no? So well, maybe if you build like a pyramid, so most of the bricks there in the pyramid are compression, but nowadays it's not practical to build a pyramid because of maybe like, well, a pyramid can be replicated, but how about the cost? No? So only very few can build a pyramid scale of building. Why? Because of the expense to build it. No, so that's not practical. No, so even if you know how to build a pyramid, it's not gonna, it's not very something like profitable anymore. No, why? Because nobody will, or only very few, or nobody will build a pyramid nowadays. Okay, so besides structure also have members that are subjected to tension. So if you are going to use plain concrete only for the structure, it will be very brittle. No. Okay. Although in older times they use stone and concrete, but those those things, those structures are have to be huge, gigantic, uh, very big in scale, no? So that the tensile will be compensated, no? Because it is bigger in construction like itong mga temple, palaces, mga castle. So before they are built with very little reinforcement or no reinforcement at all. But usually also the scale of the blocks they are using compared to the blocks we are using now. We are using a very small blocks. Before, their block is big. Like for example, if you go to the older church, like you go to in Bohol, there are a lot of older churches there. So most of the buildings there are uh, most of the old buildings were constructed using maybe plain concrete or masonry, which do not have or less reinforcement only. But if you compare the thickness of the wall of that building compared to the wall today, so the wall of the structure is extremely wide, no? While the practical thickness of the building is only what we have now, no? So you're not going to build a nuclear containment structure. You're not going to build a doomsday house. So uh, you're just going to build a practical house with affordable cost. No? So and that is to make the wall thin, the columns and beams smaller. So so that many can afford it. No. So those structure that is constructed with plain concrete have to be big, and then they are also prone to to collapse, no? Because just like what happened during the earthquake in Bohol, so most of the old churches uh, collapse because they have no reinforcement. If there is no reinforcement, once they crack, they will just crumble. So that's it, no? So that's already the collapse. So that is why we are not going to use plain concrete because concrete is only strong in compression and it's very weak in tension. And as we know,
Wakey, wakey,
beams are
wakey, wakey.
subjected to bending, and once the beam bends, there are always two possibilities. One side is in tension, one side is in compression. The compression side, if you are using plain concrete, is okay, but the tension side, there is a problem because it will crack. Imagine if you have a glass, you bend the glass. Okay, you have a small piece of glass, then you try to bend the glass. It will just break easily. It cannot. It's not like steel wherein if you bend it, it can bend. No, you can even make it into a U shape. No, U shape without breaking it. But you cannot do that to glass. You cannot do that to concrete, to plain concrete. Why? Gamay lang kayo pang binding, bubuto na rin siya, babali na rin siya, no? Ang wood is okay, it can sustain a little bit bending but not too much. Once you overbend it, it will also break. But if you put some reinforcement, especially steel which is very very ductile, no? Bisan pag imo nang mukuha kag alambre, imo nang bahugo ng alambre, wala pag mapilo na siya, dili na siya maputol. Okay? Meaning nga taas yang pasensya, taas yang agwanta. So, unsa may buot pasabot na na ang steel kung imo day siyang i-reinforce sa concrete nga weak sa tension, especially kung imo pag if you put the reinforcement on the tension side, you will produce another bed of material called reinforced concrete. And because of the strength of steel, which is reinforced on the tension side, the new material, which is called reinforced concrete, is much stronger. Okay. Okay. So much if you still put reinforcement on the compression side. So your reinforced concrete will the strength will appreciate, no, and it could have very uh, durable, produce a very durable concrete. So that is why our subject reinforced concrete. Okay, we use them in structure, even tall structures. We have buildings here in Cagayan de Oro that is they are building already 33 stories. No, so they are using reinforced concrete. So they are using concrete and steel bars as reinforcement. No, so that is what we call reinforced concrete. So uh, this subject is actually will be your guide in designing reinforced concrete because in this subject we will discuss the mechanics of the design, no? How to design basically, you know, how to design. So at the end of this summer, you will learn. No? In fact, in your laboratory, I will let you design a building and a bridge, no? So, like that. Ang bridge, kadito man ang bridge, kaya nga, no, mura man na siya beam, no? Beam man na siya. So, if you notice, no, some of you have already uh, uh, done their on-the-job training in a construction company. Most of the public project that we can see around are bridges and buildings. So bridges requires only a beam, which we call girder. No, once you have the girder placed from the other bank to the other bank, so it requires only the flooring where the vehicle will pass, where the traffic will pass. The flooring, which is also made of reinforced concrete, is being carried by on the back on the back portion of the girders. No, so you can view the girders as simply supported because they are just placed on top of the abutment on the other bank and the other end also the other bank. So you will have a simulated pin and roller, no? And then the beam length is the what we call the girder. And then the load are basically the flooring that is put inside and the weight of the girder itself. And then also plus the traffic that will pass. No? We call them live load. So the girders are if you have seen them, no, they are constructed away from the river, no, because that's what they call a construction method. They are precasting it, and once the beam are casted already, they're already strong. They will carry it because we have the equipment already. We are already in a time wherein we have the lifting capabilities, no. We just use the crane. Then the crane will carry the heavy girders and place that on its one position. Now, if you have five girders, so you place them in rows. So you have a lot. You have already a bridge, but still it's not yet a bridge because there is no flooring. Okay, and then they will construct the flooring. Okay, so that's how the bridge is done. So it symbols like one girder of it is something like symbolizing a simply supported beam, because the manner in the girders are being positioned on the banks of the river, or we call them abutments, because you're not just going to put it on the bank, no, as it is. You have to construct a structure there called abutment, no. Abutment are what we call the support on the left and the right bank of the river, no. They are not just soil, but they are just constructed support, no. In fact, most of them have piles, have foundation, good foundation that can carry the combined weight of the bridge plus the traffic that is passing it. And then it's not only that the side is protected from erosion, because uh, aside from the traffic that is passing the bridge, aside from the weight of the bridge, there is always a threat that the bridge will collapse due to the river that is flowing under. No, every time the river will flow is a potential to scouring and could let the foundation collapse. So like that. So much more if there is bad weather like typhoon. So the river velocity will increase, even the height of the water will increase. So those are the challenge in designing bridge. You don't have uh, uh, that when you design buildings. But aside from that, also there is also earthquake, which is constantly uh, threatening the structure. So to avoid that, you should also design the bridge and the building to resist earthquake. No? That's why you take also earthquake engineering, so that you can uh, determine the load due to earthquake. Anyway, uh, our topic is only reinforced concrete, but I cannot help mentioning that because these are the loads which we are considering in designing bridge. So when you are going to design reinforced concrete, you still have to determine a load, no? So you still have to make your structural model. No? So once you have the model, you analyze it and then determine the what we call the required forces or the demand forces. Okay, and then once you have already the required forces, that's the time you are going to design a section, no? Which how much enforcement is needed. It's up to the required strength, required forces. How big is the beam? So it depends, no? So it's like that. So right now you cannot uh, uh, still do that, no? So but slowly I have already reminded you that where to put the reinforcement, no? So first I remind you that concrete is weak in tension. And if you are going to use plain concrete alone, it's not going to work. It will collapse because structure have tension. You cannot avoid tension. Okay, you can maybe minimize, but you cannot avoid it. But if you are using plain concrete, it will surely collapse because gamay lang kayo ang tension sa concrete mo, crack na siya. Once it cracks, it remains cracked. Now there are ways to repair, no, but somewhat expensive, but there are, no, by just like using high pressure epoxy, no. The slang name is epoxy, but it could be concrete adhesive, no. There are what they call the technical terms for that, but if you say epoxy or concrete epoxy, still they will understand you, but there are proper names for that, no. So anyway, our topic is not about repair. We are going to design a functional section which could resist load. Now, any section have different type of resistance, no? Any section, depende sa gidakon, depende sa reinforcement, is doon na gina siya iyang kaugalingong strength. This can be computed based on the actual size niya. No? All I can say is that kung reinforced concrete section which are bigger, have bigger, generally have bigger resistance compared to smaller reinforced concrete section. But that's not that malo because still it depends on the material. Remember that concrete can be made weaker and can be made stronger if you just vary the amount of cement. You just increase the amount of cement will increase the strength of your concrete. So if you observe the water cement ratio, because water is if you have too much water in your concrete, it will also decrease the strength. Okay, so there is a what they call that appropriate magnitude of water cement ratio for every concreting. Dili pwede nga mabutang kag alas og tubig nga butangan natin 10 liters nga tubig, no? So it should follow the formulation actually, formulation. So all of that is being discussed in I think there's a subject for that too, like material testing, wherein you are going to make your own design mix, no? So until you have what we call design mix that will produce that strength, because concrete could be variable in strength. It depends yun, no? Kung sa kadaghan imong simento, sa kadaghan imong graba, yeah. Sa concrete naman siya. Ang reinforced concrete magdepende sa mga strength sa materials. Pero duha man ka materials ang sa reinforced concrete. Number 1, concrete. Number 2 is the steel reinforcement. Mao gina silang duha ang atong idulaon sa pag-design. Okay. So I'm still stuck with the concrete is weak in tension. That's why we have reinforced concrete. So the second thing that I am telling you is that you reinforce on the tension side. So how to look for the tension side? Diyan na makita ninyo sa inyong analysis, no? Sa inyong analysis. So doon naman kay building, i-model, i-load nimo how it is loaded in the actual. Then after you analyze it, you can determine the tension side of the beams in the column. So that's where you reinforce. Now sa column, which is under compression, that doesn't mean that concrete is very strong in compression. You don't put reinforcement in column because column are mostly in compression. That's not true because sometimes column have tension. Okay, remember when the wind will strike to the building, or earthquake will strike to the building, the load is horizontal. So there are times that the column will be under tension. So if your column is not reinforced, so when there is earthquake, so some columns will just crumble because they will experience tension. And remember that concrete is weak in tension. So that's why you leave no member unreinforced. There should be all the members should be reinforced, starting from the foundation, which is what we call the reinforced concrete footing. Then ang sumpay din niya column, which is reinforced concrete column, and then we have the beam, which we call the reinforced concrete beam. So those are you have also what we call the reinforced concrete slab. So all the materials you are using in this subject are what we call the reinforced concrete. Bisan pag beam na siya, bisan pag column na siya, or that is a footing, or that is a slab. Now, in this subject, I will teach you how to design footing. I will teach you how to design a column. I will teach you design beams and slab using reinforced concrete. Okay, so that is our mission that is my mission for you class. Okay. We will start now, no? So little by little. So I will Uh, we will see what's time now. Okay, so I will present something. Okay. Okay, so this is our so you see that concrete is weak in tension. No? It is weak in tension. Okay. The reinforcement is needed in tension zone. Okay, so reinforcement is also posed on reinforcement is needed in compression zone. Okay, to increase increase strength, to increase strength and reinforce against against uh, reversal stresses. This reversal stresses class is like for example, no, you have you have you have a simple beam, no, simple beam like this. Okay, let's say that this is the simple beam. I will just draw a simple beam. Okay, I will format that. I'll make it to bigger one. Maybe 4. Then I am going to put a reaction. Say that this one is the reaction. Okay, I will make that big. Okay, and let us say there's also a reaction here. Okay. Now let us say that the load is there is a load here. Load. This is loaded. I will just make a symbol of the load. How will I make a symbol of the load? Ano na lang. Tangan na nato kuan. That's the load, no? Now, this load could be that load could be okay. So let's say that is the load, no? Now, if you are going to do the depicted structure, I hope you will agree with me with this. It will be like this. Okay. Uh, this is the depicted structure. Okay. So that is the depicted structure, no? So from here you have two types of chord. Okay, one is opening up and one is opening down. Okay, so uh, that's the one. No, that's only if the load is going there. But don't you know that there is a possibility that this curve will will reverse? Okay, so if there is a reverse, so for example, in this type of configuration, no, so the configuration for this one, if you have a curve like this, where how to make curve here? Wala, let's say curve. Akin na lang. Ay, ko pangit. Pangit. So anyway. So in this case, if I'm going to borrow this one, okay, I will separate that one and identify the tension. So I will put tension here. No, uh, I will make this one. So kung mao ni iyang depleted structure, no, depleted structure or deformation because of the load, mao na iyang depleted structure. Now, our task is to find the compression, no? Compression and the tension. So here, because this is compression on the other side, but if you move further, it will become tension because the curve is changing from opening upward to 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 opening downward. Whereas if you check at the bottom, this one is tension. But as you slowly go to the left, this will become compression. Okay. So that's how it is. Okay. Now, if your beam is like this, oops, if your beam is like this, so uh, where to put reinforcement? Where to put reinforcement? Now, I've told you that you reinforce on the tension side. So if I have a beam, if I'm going to make a beam here in with a depth, so my beam could be like this. No? This will be my beam. Okay. So here you have the depth, no, of the depth of the beam. Okay. So I will take away the color. Okay. Okay. So if I'm going to put a reinforcement now, siguro akong pinanglanan eh. Okay. So I will add a support para reference ninyo. Okay. Kana tog support ya. Okay, I support ya. So ang beam ko ni dako, no? Ni dako ang beam. Okay. Then I will copy that. So this one is unreinforced beam, no? So if there is no reinforcement, uh, no reinforcement, uh, kang nato ato ning kopyahon. Okay. kung no reinforcement, no reinforcement, okay, once the load is there, the tension side occur at the bottom and at the top. So what happened to your structure is it will become like this. It will become like this. It will become like this. That is what will become to your structure. Why it's like that? Because the tension side cracks, and cracks will just propagate until to the other side. Because so that is what happened to your structure, no? So it could not be it could not collapse when there is no load, but I doubt that because the weight of the concrete alone is already a load. So maybe it only stand for a very short span, but if the span is longer, moment is bigger also, no? Because moment is a function of the length or the span. Like for example, the formula for the moment of simply supported beam is W times L squared over 8. No, that's the maximum moment. Okay, that is only for the dead load, no, for the dead load only, no. So this is what will happen. Now we do not want this to happen to your structure, so that's why we will make other way with the enforcement, with tension reinforcement. Reinforcement, of course the reinforcement is steel. Okay, so we'll copy this, copy, paste. So this is what will happen. So if I'm going to enforce the, say, the the tension side is here. So I put some reinforcement here. I will color that. Nakuha ko na siya. I color that of red. Put the reinforcement there. So this one will not crack. But how about here? I will also put the reinforcement. Okay. Now, why not put reinforcement in the middle, only on the bottom? Because the middle there is not there is very there is a there is no tension, there is no compression. So that's why uh, in some okay in most reinforced concrete section there is no reinforcing bar in the middle, no. But uh, that is just uh, it's not two per column, no. Not two per column. It's only for two for beams. But for deep beams, you still have to provide reinforcement. But most of the this is the idea of the reinforced concrete. You reinforce on that so that when the load acts, steel is very strong in tension. So it will just show some crack, no? If the load is really very excessive, what will happen? This will just show some cracks, no? Show some cracks. Let's say here, there is crack here. So it will just show like that, no? Crack up to the. It will just show some crack, and cracks are allowed as long as there is enforcement. Okay? But that is a disadvantage actually of the concrete if there is crack. Why? Because that will serve as an opening for oxygen to penetrate and cause corrosion to the reinforcement. So uh, it's good to have a crackless concrete or just maybe a very thin crack, no? That the oxygen cannot pass. That's in most concrete they're designed as uh, crack section, no? Because tension in concrete is not really part of the design. It's only the compressive part of of the concrete is designed. So cracks in concrete sometimes appear, no? Because maybe of the load, but it could be better if there are no cracks. Okay, so crack also appear on the upper side. Okay, here I put a crack here. Now where is the crack will occur? Of course, pag itaon ni mong tension, ay tension din taas. So nani siya crack niya. So para po, nani siya crack din. Okay, ayan na, kita ka crack niya. No? Ang crack pag yun, dili pag na siya kaisa lang, no? Ka na ba multiple crack sa mga near kay mo man siyang heavily stress sa tinsel, no? You can have multiple there, so diyan ng mga area na crack. Similar to the location of the stretch mark, no? Asa man stretch mark makita dito sa place nga na ang maximum nga stretching. Kay mas stretch man gud siya, may tabuan na niya pagbawog niya na, mas stretch na siya. Kung ma-overstretch siya is mo inat siya. Now, daobi kaya ang concrete is weak man sa tension, so there's no much stretching. After little stretching, crack formation will appear in concrete, and once it cracks, it is always cracked. Okay, so dinilapit na siya din. So that is where the location of the crack. Okay. So, but this one above cannot happen. Why? Because it's very difficult to stretch the steel, and it still is there. Even if you stretch it so much, it will not break easily. It's still there. Elongated version of steel is still there, but not necessarily nga putol siya, no? Because steel is known to proven to be very ductile material, no? Sa gamay lang siya kayo, just like what they use sa mga crane, ganang mga steel cable niya, nga ang pag-alsahon niya, gabi kabugat, pero ang gadakon niya, gamay ra kayo na siya, no? About 1 inch ang diameter dana, no? So, muna gagamiton sa mga lifting na mga equipment, no? So, with alsahon na niya, kayo mo sa taas, so, dili siya maputol. Okay? That is the property we need as reinforcement para this situation nga nasa taas cannot happen. Okay? Anong nahitabo mo siya? Kaya nga no, wa man siya yung reinforcement. Okay? So, even if this one, you know that you need attention reinforcement is already a good start to design reinforced concrete. Now, sometimes when there is earthquake, may tabo nimo muuyog ang structure, no? So just like if you stay in the middle of Marcos Bridge nga puno ang traffic, so makita nimo nga mag-uyog-uyog. So pag uyog-uyog niya ana, ingon na ang posisyon niya. Una na ang posisyon niya pag uyog-uyog niya. Mo-reverse ang kuan. Na chance nga mo-reverse. Nga labi ito po nga nung nako sa tunga sa tulay, musaka man yung sakyanan na, paingon na sa ubos. That means nga, niuyog siya vertically. So, ingana siya, no? So, magbalik-balik siya. So, imagine kung naaka din nagtindog sa kuwan mo, ana. Uh, if we are going to observe this, kung ato na siya i-observe, kung siya itawag og stress reversal, may tabo na siya kung mo-vibrate, no? Magbalik-balik siya ba? Mga bagpindulong to the other side, Mga na siya glubi, nga gihangin-hangin, nga mo ato siya sa left, ato siya sa right, mga na. So, ni uyog siya, no? Ni sway siya, no? Ni sayaw. Ni ana-ana siya. Okay? So, in that case, ang location sa tension niya ito sa taas, no? Kung ako po'y tao ng tension na ni kay compression din eh. Ano sa kay tension niya? Reinforce mo na itong concrete. Wala problema. Reinforce. Pero asam sa reinforcement? Dapat sa tension kung yung kadani nga nahimo ng tension ana tungod sa pagtayog niya. Makita nimo nga wa man kadai nabutag reinforcement din sa butong. So collapse gyapon din kung imunani ang imong figure. Okay. Now sa tunga ang tension na sa taas wala sa ubos. Wa man kay kabilya gibutang sa taas. So, we go back here. Reinforcement is needed in the compression zone to increase strength and reinforce against reversal stress. So, wala man ka tension naman nang i-provide ani, okay lang na siya kung dili maglinog, no? Kaya pag linog mo, tayo og gina siya mo labi na og up and down ng movement sa acceleration na pagkuanan na niya, ingani gina siya, no? Kuana, siya balik sa ngana, ana sa so kuan siya, balik-balik siya mo siya kuan. So, this one is okay na unta, pero kung maglinog, wala pa gyapon siguro. Tingnan naman, mabalin naman ang tension niya. As you see, wala man mo yung sa tension. Ang tension na naman sa taas, naman sa silong. So, still this one is not a good idea to reinforce tension only. But, okay lang ta, no? So, with kung akong butangan with tension and compression reinforcement is ingunahan niyo siya. Tuling kopyahon. With tension and compression reinforcement. So, ano siya? Ito na lang siya extend. Ito na lang siya. Siya reinforcement. Ito siya extend. So, kung doon na may reinforcement sa top o sa bottom, dili na ka mag-problema ani kung maglinog. Okay? Kaya kung maglinog na siya, magbali-bali yun ang iyang kuhanda na iyang deflection. Okay? Nga naman ang pagtayob, no? Usaka ka, maubos, ana. Kung naka sa tunga-tunga sa bridge, mga imong feeling nga, gitos up ka, niya matulog sa ubos, no? Just because of the vibration of the engine. Even wala siya earthquake, nga uyog man siya, tungod kay na may nag-uyog-uyog, no? Bilang ikaw naka sa tunga-tunga sa bridge, kanang beam, nga lita si wooden beam, niya maglukso-lukso ka, tungtay og siya, no? Muuyog siya. So, mugo up and down ang deflection sa imong beam. Now, mugo up and down, mao ni siya ang figure niya. Will become blue, and will become red. Yan na, so balik-balik. So, there is also magbalik-balik sa daasang tension, depende sa iyang shape. So, if you have a tension and compression reinforcement, you do not have to worry about this deflected structure because every possible nga tension side, whether walay earthquake o may earthquake, is provided. So, this is a good reinforced concrete. Okay. So, okay na unta, no? Why? Because kung imong tanawon sa moment diagram, no? Tara na to ang moment diagram. Moment diagram. Kung ang loading mo na, no? Kung ang loading mo na, ang load. So, may loadan. Kini siya, no? Kini. Ang moment diagram. Ito how na yung moment diagram. Ang moment diagram niya ana is kung ani. Moment. Pinindot pa mo sampo ka sa moment. Okay. Moment diagram. Sila manlagma lang ta. Moment diagram. Yeah, insert tayo sa shape. Okay. Okay siya moment diagram. Insert shape. Kung hindi mo na moment diagram. So, yan. Okay, anyway, last open. Okay, mao na siya ang moment diagram niya. Okay, mao na ang moment diagram niya. Okay. Sa vertical load only, no? During stress reversal, mabali-bali ni siya, no? Baliktad ni siya. Okay. So, if you have this reinforcement, ang tension side is already taken care. Even kung doon pa yung earthquake, mabali na sa tension sa taas, nagya po yung reinforcement. Pero kung wala yung earthquake, mo serve siya as compressive reinforcement. Kining na sa compression niya. Ang yung function na mo increase na siya sa strength sa inyong beam. Okay. Your beam will become stronger than it is reinforced only using tension reinforcement. So, para mo improve ang capacity sa imong beam, mo provide you compression reinforcement, no? Compressive reinforcement. Okay. And also, para sa accidental nga mga stress reversal. Okay. Dabi na subjected to dynamic load ang imong building. Okay. So, that's it. Now, how about the shear? No, shear. So, ang shear is also an important. That's why we provide the shear reinforcement. So, because there is shear diagram. We will study what is shear diagram. Okay, say shear diagram. So, ang shear diagram niya ni una niyang forma. Okay. Yang beam. Okay. Kanya, nada yun yung shear vertical because may reaction din is musaka na siya. Kanya, mo down din na siya kahit naman sa uniformly distributed load. Kanya, musaka na siya. Nakapagigit as actually. Yan. Gini siya. Pahinga siya. Okay, muna yung shear diagram. Okay, hindi equal. Nalagma lang ko ha. Okay. 'Yan. 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 ' Okay, so muna siya yung shear diagram. So makita nimo nga dako og shear dinhi, dako ang shear din dapita. So this one is still not okay. Kaya nga naman, there is another failure candies nga mahitabo which cause ni siya og crack din dapita sa shear. Doon na siya shear. Ang shear nga crack is 45 degrees. Makita nimo na inclined na siya nga crack. So na dunay mga cracks mo form din ni dapita. Okay, mo na gitawag na to og shear cracks. Shapes. Yung mga cracks din. Also, on the other side, the co-shear, nasa na siya matabo din. Dili na siya dili na siya. Kining mga vertical mo lang itawag og textural crack. But this one is what we call shear cracks kining katakilid. Okay. Now also on the other side, nagyak na siya din. So, ang mahitabudan na niya, kung dili mo siya na-enforce sa shear, with no shear enforcement, so may mahitabo. Well, ato ning balik dito, kapyahan ka siya o copy. Okay. So, siya ito. Musay may tabo sa beam kung wala shear enforcement. O kinangta siya kaya doon na pictorial enforcement. Pero if you look at dako ang shear din high stress ni siya. Dako ang shear din so silang wala kay shear enforcement. So you don't need shear enforcement. Pero nagingon ang code nga bisan og walay shear mabutang lang gihapon ka, no? Mabutang lang gihapon ka. So para makuan kay ang load usahay labi na og moving mo usab-usab ay imong shear diagram. So basin dili na ni siya imong zero. So this zone here have shear enforcement. So ang mahimong failure ana niya is ingon ani. Kung mopabagit jud pagayo ang crack ana niya, moabot dito sa taas, mahulog ni ba kung kini siya moabot dito. Wala si Parit na kay once ma-crack na kayo siya, kung kayo is always crack. So, we will not let that happen. So, kasi nga na lang dihan. No? But this one is already a sign nga so, if there is a shear enforcement, there is still reinforcement that can hold the rest of the concrete. So, what will happen kung wala shear enforcement? Well, atong analyze. Insert the og shape. Huwag yung unahan yung hitabo ba. I hope na i-shape nga na akin nila. Okay. Patuloy na siya. Okay. Flip. Okay. Evidencia. Copy. Yes. Okay. Copy. Paste. So, ato na siya butang diyan, no? So, butang na lang color. Ato na siya. Tingnan on. Nga, ato siya ipula. Okay. So, yan ang may kabot niya. Sinasibog na siya dito. Sinasibog na dito. Hindi yun. Ito na siya. Okay. Ito siya ng pula. Ito na. Pula. Yung okay. So, ito na ito, nihulog na siya. Ito sa expecting dito. So, yung ana ang may tabo niya. Okay, so, siya 45 degrees. So, yan, hindi niyo ko na nakita. Ano siya diyan? Now, because of the shear, so, yung ana ang may tabo niya. O na siya ang shear failure. So, mahulog lang na siya kung extend ang crack niya pero dito, no? Kini siya kung extend ang crack dito, ano mo crack ang sab mo kay dako lagi ang shear. Okay. So, we need some shear reinforcement. So with shear reinforcement, so ang imong section is ingon ani. So, naana siya ay ingon ani. Ano to? Blue lang. Napupihan din na to. So, ano to lagay na shear reinforcement. Ano to sa mga area na na-shear. Provide like shear reinforcement din. Tungod kay dako yung shear force according sa analysis. So analysis is your window. Kung ang analysis is mo gina imong pinaka dili nimo makuha ng tool, no? Kung electrical engineer pa ka mo na ang imong tester, kung doktor pa ka mo na imong stethoscope kanang analysis nimo nga diagram. So if you have a reinforcement like this in a form of a ring, so even though do na kay ingon ani nga crack, na kay crack nga ingon ani, naapay nakapugong sa iya. Okay? Dili ka mabalak ka nga mo-collapse siya, no? Doon na pa kay time nga maka-rescue sa imong beam by adding some reinforcement if needed. Okay? But cracks will not appear kung maayo pagka-design ang imong beam, no? So even if you have that crack, tuturuan si Mike. Even if you have that crack, Okay, kung nakakaana, pag hindi siya mahulog yung ano, nagbitay pa man ang steel na diyan. Steel na diyan. Yeah, kung closer imong reinforcement diya, daghan kayo mo siya reinforcement. So, lig-on gid siya, no? Now, with shear, with flexure, and shear reinforcement, mo na siya ang complete yun nga reinforcement. This is the complete. Kaya ang shear, mukhaan mo sa resistance torsion. So, butang ka din eh. Kaya kini ay sa kaya kini mangud kulba mangud ni siya kung shear reinforcement mong gibutang. Dobi kinaman sa movement, ang movement maximum dia. So, posible nga nasa mo crack din ni, no? Nasa crack din ni dapit oh. Kabalo mo asa dapit ang crack din ni. Nasa crack din ni. Okay, crack na siya gitawag na to flexural crack. Okay, may flexural crack. Nya, ako ang maximum moment dapit. Kini din ni maximum, no? Nya, aman dapit ang tension to sa taas. Kung walay linog, ha? There is crack here. We call this flexural crack. Okay? Now, kung wala ka reinforcement din eh, so mitabuda na, yung unaanig hapon, this is what will happen. So that this kind of failure, and this kind of failure will not happen, so you should put flexure and shear reinforcement. So mitabuan na nimo is, copy, paste, butang. Okay. Now, butang na ito, reinforcement, insert, so gamiton, kini ang problema lang sa nga color, pula lang ito gamiton. Okay. Okay. Yan, itong bagaan, kaya para, okay. Kaya hindi na ito. We call this a shear reinforcement, main reinforcement, flexural reinforcement. Yan, kini, ito siya ibutan din. Muna siyang shear reinforcement at ulan change yung color para mabagay siya. Copy, paste. Ito na to, naka-shear reinforcement. Let's say din di naman kaya kinahanglan so lagyo lang yang reinforcement. Lagyo na to. So, pero naagit siya kaya na may minimum requirement. Din the pita, medyo closer siya. Yung ano man, ako ang shear, tapos diagram na ko yung shear. Tikas na yan po. May shear din. Ito na to. Okay. So this is now a complete reinforcement. So you don't have to worry about the flexural crack because there's main barrier. Bisag asa pa siya mo form, ikaw balaka sa ingani nga failure, kaya na kay gitawag og shear cracks because you have shear reinforcement. So this is now what you could do. So this is the reinforced concrete section nga dapat nato i-design sa beam, even sa column. So na siya mga reinforcement for shear and moment or flexure because we need reinforcement because mauman na siya ang force nga nasa diagram, no? May line force. Okay. So I hope na nakita ninyo kung how we are going to reinforce our beam, no? Wala pa ta sa calculation ha. Ato lang is we provide the reinforcement on the beam, no? On the section. Now, it does not only apply to beam but as well as column. You provide reinforcement everywhere because sometimes the tension is not staying there forever. It could change to the other side. Anong mo change mo sa to the other side? Because of the dynamic loading, no? World is changing. Okay? So, it's not always nga naadi ang side ang tension. It could be nga ubalhin sa pikas. Now, kung wala to nimo butangan og tension o enforcement, patay imong beam, mo crack siya kay ngano concrete is very weak in tension. But concrete, if bisan pag naa siya tension pero na-reinforce siya, mo crack man galing siya pero dili siya kadayon og crack ngano man, there is a reinforcement inside. And steel is very strong reinforcement. As I have given you an example ganiha, kanang mga steel nga gigamit nga kable sa mga crane, mauna siya ang mga properties sa steel nga nasa mga beam nimo, no? Kung doon na kada na, bahala pa siya pila pa na katinilada yung timbang, di siya maputol. Unya, kung muinat naman siya, muinat lang siya tungod kay nasubara ng force ko, di pa gid siya maputol. Taas ang iyang pasensya, no? Kung tao pa siya, kung bisan di mo siyang ulit-uliton pagayo, di gid na siya maulit. Ang concrete, gamay ni mong storya, masuko na dayon muna siya ang kwan, ang analogy bali. So, is the patience, no? Patience of the material from breaking, no? Steel is have very good patience, especially kung tension. Pero compression sub, ang steel nasa deficiency kay ano man, as we know in our steel design, steel is subjected to buckling, mubakol siya, no? Mumulhod siya, no? Mubakol. So, you know what's buckle, no? So, now if you supplement the weakness of the other by a strong material, like for example, ang concrete is weak, but you supplement that with a strong material like steel, the product or the result would be a stronger hybrid material. No, it's called hybrid because it's composed of two materials, which is reinforcement and concrete. So call it reinforced concrete. So I have already illustrated why there is a need of reinforcement, both the fixture and the shear reinforcement, and then also the importance of reinforcing the stronger side of concrete. No, we think that we do not need reinforcement, but remember, strength can be increased if you provide more reinforcement, and also we do not know that earthquake will come, will change the location of your tension. You do not know where the tension is. You can only simulate that in the computer software. No, if you have a model of your building and you apply earthquake, so if you observe the building sway, so in swaying, there is a movement of tension zone. No, and I'm concerned of the tension zone because that is the weakest side. No, so kung panalitan na kay mga nakay-heard sa mga kanding, katong kanding ng mga week kayo mo imong after, no? Ay mo gyud siya matimanon nga kuan. Katong mga ligo na, no problem to sila. So taman nga ma-strengthen na to nimo mga luya nga mga kanding that's the time you pandem, no? So you look on the weaker side, no, and then reinforce it. That is what engineer can do, no? So tanaw ka dito imong structure wa man ni tuko imong structure bay. So atutukan ni dinhi, okay kay ngano man basig matumba na ni pagkauma, so daghan kay mga balay sa payag sa mga slum area nga they do not know, no, ilang balay nagtakilid na nga gisig unsa na nila reinforce di gyapon masubar bag takilid. Pero kung na-engineer dito, tayo naman ni bay tukhan naman nimo na abutangan naman nimo ni dinhi. So ang imong gibutang nga reinforcement sayop wala na siya nagtrabaho. It's just like reinforcing a concrete and putting the reinforcement in the middle, no? Nasa middle. So wala na mo reinforce ang concrete side. Nagsayang-sayang lang ka butang og reinforcement. Nya abi nimo nga dagko kayong kabilya imong gigamit pero wa day siya nag-function kay ngano man imo man siya butang sa tunga sa beam, no? Wa man dito ang tensyon. Ang tensyon naa sa extreme nga side, naa diha magsugod ang crack, naa diha magsugod ang mga stretch mark sa mga extreme nga side. Okay? Wala yung mag-stretch mark magsugod sa sulod paingon sa gawas. It is always starting at the outer side. So that's how crack formed. It started from the extreme uh, side of the beam. Pinakalayo, no? Pinakalayo. Okay, so I will take a break, no? After this, we will do some a little computation, no? So it's good na we know that concrete is weak in tension and we know how to enforce a concrete. So even though we know weaker siya sa tension and we have, so that's good, but as I have said, it's not enough. Now you put top reinforcement at the double reinforcement, so you think that is good enough, but no, dapat ay shear. So buta pagiging shear reinforcement. Once you have the shear reinforcement and the pixel reinforcement, that is what we call complete reinforcement. So that is the type of section that we are producing. But as of now, we do not know how much reinforcement we will put because we have no calculation whatsoever. We do not know how big is the beam. We do not know how wide it is, how deep it is, because it needs calculation. No, it needs to be based on the required strength of the structure. Okay, it's good that we know how to reinforce it and where to place the reinforcement and the importance of placing reinforcement in the other side also, like making it double. Also, the importance of the shear reinforcement to avoid those cracks to propagate and cause failure to your structure. Cracking, if you saw some cracking in the reinforced concrete, as long as it is reinforced, it's not always a problem. As long as you see it nga dili siya problema. But if you see a beam nga grabe na gyud kayo ang nagpakitabang na gyud ang beam, kanang gatakilid na gyud siya, kanang gyud dagko na gyud kayo ang crack niya, nga makita na nimong kabilya sa ilawom nga nangainat, that needs a repair already. Okay? So, yung kinahanglan ni siya tabangan. So, ato na ni siya i-repair. So, daghan sa paagi ang pag-repair. So, lain sa na subject ng retrofitting, no? Saan yung pag-retrofit ang structure nga na-damage na. Kung dili, ang structure daan na kayo, dili mo gusto nga mo sa forma. Yeah, like for example, doon na kayo tawag nga tawag kaning term anin niya. Heritage building, no? To nalaning gubaon, dili ka kaguba kay nga naman heritage building mo siya. So all you have to do is retrofit. Mao gyapon yang forma pero it has already been strengthened and respan, no? Nang ingay strength dili na mao, just like what they do with the tower of Pisa, no? In Italy, no? So nagtakilid ng building, pero dili na gusto pa-straight kaya naman kung ma-straight na sila, wala na sila yung makwarta because people will go there because they want to see the tower, leaning tower of Pisa. So kung ba doon lang ay, wala naman din nagtakilid ay, giayo naman, wala na sila income. Okay. So, ang ilang gibuhat is mao lang yapon patakilid lang yapon nila pero ilang gi-reinforce pagayo ang yuta kay dino nga kung dili tunlay yo enforce, night time nga mo collapse gid siya. Okay. So, okay, I will take a break. We'll have 20 minutes break.